All right, there we go. So the system of linear inequalities is a system consisting of two or more linear inequalities in two variables. The solution, there's going to be a bunch of ordered pairs that would make both inequalities true. And the graph is a graph of all the solutions, which is what we're going to do today with our colors. Okay? So here, we have two inequalities, and we're told that they're a system. So let's graph both of them. You could do one in one color and one in another color because it is kind of cool to see the overlap then. So I'm going to start with this one. I start at 2. I use the slope to do up 3 over 1. Okay, and then is it solid or dashed?
Solid.
Solid. So I connect those 2 points with a solid line. Now some of you can see when it's in y equals mx plus b, this is just a trick. If it's y is less than, that means that it's all the y values less than. And if you want to use that trick, you can. If you don't, you want to just test with 0, 0, test with 0, 0. So I'll do that. I'm going to test with 0, 0. 0 is less than or equal to 0 plus 2. Is this a true statement? Yes. So I shade everything below, not too heavy, just kind of lightly, because that's that one. Now do the other one with a different color. You don't have to, but it's kind of fun. So here, we start at 4, and then our slope is -1 over 1. That's our slope. So we go down 1 over 1. Stop. As I said, we start at 4, and we go down 1 over 1. Okay? And then stop, is it a solid line or a dashed line? Dashed. Connect it with a dashed line. Okay, now we got to decide what side to shade. If we plug in 0, 0, is 0 greater than 4? Is that a true statement? No. So we shade above. Okay, so really all you're looking for is the overlapping part. So if you shade the whole thing, that's fine, but your solution set is where both colors are. So that means that any point in this area here, any point, would make both those inequalities true. Got it? Do you remember this?
Yeah.
Yeah. Okay. Okay, turn it over. All right. Sometimes you'll see some different things going on here. So let's graph this. This I like to do since it's in standard form. My preference is to just make the little XY table. Yep. Set it equal to equals, and then make the little XY table to get your 2 points. You could move it into y equals mx plus b. It doesn't matter. So if x is 0, y is 4. If y is 0, x is 2. Then I plot those 2 points. Over 0, up 4. Is it solid or dashed? Solid. Make it as straight as possible. And then I plug in 0 plus 0. Is that greater than or equal to 8? Is that a true statement? Is that a true statement? No. So I'm going to shade this side, because 0, 0 does not make it true. Okay, let's do the other one. So here, I start at 3. It's in y equals mx plus b form, so it's really easy to start in 3. Use your slope to get your second point. You go down 2 over 1. Solid or dashed? Be careful, make them as straight as possible. They are parallel. Now, if I plug in 0, is this a true statement? Yeah. So I shade the side that has 0, 0. Oh, there's no overlap. No overlap. No. But what does that mean when there's no overlap? This you should write. No solution. Okay? All right, let's see what happens here. Okay, again, I have a y is less than 2. If it helps you, think of it like this. What kind of line is that? That's telling you all the y's are what? All the y's are what? 2. So what kind of line is it? Horizontal. 0 slope. It's a horizontal line. Okay, so I'm going to draw a dashed line where all of the y's are 2. Dashed line. Pardon me? There is. Now this is saying that it's all the y's are less than 2. So if you look at the y-axis, which way would you shade? Below. If you don't know, you could certainly stick 0 in there, and it would show you that you do shade below. Okay? All right. Let's think about this one. We have an absolute value, but it's a -1. So which way did the absolute value graph shift? To the right. It's inside. It's inside, so that's the left or right, and this is to the right. So we're going to put our vertex right here because it shifted to the right. Is it going to be solid or dashed? Okay, so I'm going to draw like this. It goes through this point and this point. Is it just shifted to the right is all it did. Okay. We could test with 0, 0. If you need to. You may not need to. You may be able to see what's going on here, but I'm just going to test with 0, 0. Absolute value of negative. Is this a true statement? No. So where do I shade? In the upper part. Because I don't want to include 0, 0. So there's just a very small overlapping part here. It's this part right here. This is my solution. Right there. Yeah, yeah? Yeah. Let's just be clear. Anything on these lines and inside here would make both of these inequalities true. Okay? Isn't that fun? Doesn't your picture look pretty? Okay. Oh, look at this one. We got a whole bunch of stuff going on there. It's okay. Let's do this. So, x is greater than or equal to 10. X is greater than or equal to 10. Is that a vertical line or a horizontal line? Vertical. All of the x coordinates are 10. Is it going to be solid or dashed? Vertical and solid. Okay, and then it says everything is greater than or equal to 10, all the x values, so I shade this side. Okay, x is less than or equal to 70. Is this vertical or horizontal? Vertical. All the x values are 70, so it's going to be a line, a solid line here. And it's everything less than. Now wait, before you go shade crazy.
No.
We already know that this is not part of our graph, right?
Right.
So we really only have to shade to here. Okay? If you're doing less than 70, you don't need to go over this line because we already know that's part of our constraints there. Okay? All right, now let's do this one. Ooh.
That's like.
What's the y? No, it's not. It's really easy. What's the y-intercept in this equation? 0. What's the slope? Up 8 over 7. Okay, up 8 over 7. So you start at 0 and you kind of go like kind of where 8 is and over kind of to where 7 is. And then you draw a solid line. Okay? And then you decide what side to shade. Now, you can do this. Is 0 less than, well, you can't use 0, 0 because we go through 0, 0. we could use this little method that tells us that all the y values are less than our line. So which way would we shade? Below. We would shade below. Now we have constraints, so we're just going to stay within there. We're not going to go shade crazy. We just go there. It's getting a little messy now, isn't it? Then we got one more to do here. 2/7. So I start at 0, 0. I go up to over 7 is about, I'm going to do a different color, about right here. Solid line. And it's everything greater. This tells me that it's all the y values greater than the line. So it's going to be right inside here. This right here, the blue, is your solution set. Kind of fun, isn't it? You get to color in algebra. That's the solution sheet. Yeah, that's good. Solution set. That's the solution set in blue. Okay? So your homework is page 171. 3, 5, 9, 11, 17 through 29, EOO, and 35. Now let me talk about that handout that I just